This is a D10 ripper shank we're about to do today. So I've made one half cut here, a bevel cut halfway down, and it'll be ready to make this other cut, as you see. It's an 1.5 inch leg on it. So now we gotta, we'll get over here and we'll cut this other one here at halfway down. This is 5 inches deep. It's 5 inch deep ripper shank. There. It looks pretty good to me. It's 15 3/4 of an inch to this point here. The reason why that this isn't beveled out is because this shank is longer than the other shank. Don't ask me why, but the guy's got a special ripper cut 5 inches deep, which is substandard, and made the pocket a lot bigger, and now you can't fit anything into it, so we have to stick with this here shank and just weld our D10 tip onto it. So yeah, you can see it's all kind of rough here. I didn't quite get down to the point with your cut, because if you try to make the very edge, sometimes your oxygen will just kind of gouge off the edge, and then you got a little hole. So what I do is I just quickly, it only takes 10 minutes, is to go with a flat carbon and just do a little gouge along the edge of your cut there, grind it up, you're done, ready to go. Let's put it on the bench and line them up. And there you have it. There's the way I do it. I don't grind mine really smooth. I like to have it to a point. As you see, it comes to a fairly fine point along there. All my gouges, I just clean out the gouges. I want to make sure I have gouges, because if you have a smooth face, that's a smooth fusion zone breakage possibility. A rough surface is far better for your welding. I'll get rid of this here now. There it is, water on the steel coming out of it. Who would ever think that steel has water in it? There's my my cut there, the 1/16 curve. Actually, it's a 332 curve. And we're ready to go together. Let's see, put this on here. Nice little heel on the end. Good work. Let's put the root path in. Chipping hammer. They work good. See? Not too bad. It doesn't have to be perfect, but it's got to be good. There's a little heel I welded on there. And there it is, a pass of 532/70/18 at 180 amps. There we go. That's no finishing work, so you can see what it looks like. There you have it. A 3/16 weld. I didn't go in with my chipping hammer this time because it kind of dents up the weld a little bit, so it's really hard to tell what it was a good and bad weld after you pounded the shit out of it. So this time here, I thought I would just show you this before I pound the shit out of it anyway. And I will grind out those edges before I go on. Right through that crack. Because we're welding with low rods, there's not that much heat going into the shank. These things are real sensitive if it starts to contract and expand an awful lot. We want to keep an intermittent pass temperature in there. what you want to see here is some slag coming through. So you had a good root, and that's pretty good right there. Not bad, I can see it. Here we got contact with no root really coming through. A little bit of smoke, that's all right anyway. So we'll gouge that right into that weld. And you notice how much rust is on here already. That was shining when I first started. That rust only appeared in the last half hour. So it's amazing when you heat up metal, to put water to it, it rusts really quick. Let's get this gouged out. And this is what it looks like after I finish gouging it. And I didn't do any cleanup or any grinding, just so you can see how deep that is. Obviously, it's deep. We got 3 inches there. That's only half. The other side is also 3 inches. But this back gouges straight into the weld. So you can't have no cracks or porosity. Now I'll grind that up and start my root pass again. I use these itty bitty 1/4 inch gouge rods for getting in that hole. You don't want to make it too big, but you don't want to make it too small either, or you'll have a problem with side fusion on your 332 rod. So we'll grind it out. We'll get her clean. Probably put a little more on later. Let's get some welding done. One done. Pass number 1. Done. A little bit of grinding to get all that out of there, but that's pass number 1. Pass number 2. Starting to come out of that hole. Number 3, so you can get a good look at it before grinding. Pass number 4. Oh, look, that 1/8 rod, I think I can go. There's a 532. Yep, I think it's going to fit in there. Pass number 5, out with 532, in with 3/16. Pass number 6, and you see, there's what it looks like, and of course, there's a little bit of slag there. May as well have the picture of both things. Oh, and look at this, my end piece. The tip is starting to pull up that much already. Time to just flip it over and get some pulling down on the other side. Pass 5 on this side. Time to get the big guns out. 2.4 mil wire and a great big torch handle. Number 5 and 6, flux core wire. Pass number 7. That's what she's starting to look like. This might give you an idea of what it's like to be under this mask. Good afternoon. I covered it all up after pouring a bunch of heat into it because I want the heat to move out. I want it to be even. I want to save it, not get rid of it. I had some lunch. So we'll uncover it, get rid of some insulation and start. Oh, she's toasty warm in there. Woo! Ah! Woo! That's hot. The greatest thing about welding, gets your coffee hot. Sometimes a little bit too much. I'll have to let that cool now. Yep, we'll take off this insulation, take a look at what we got. Should be good. Gonna roll. Sometimes when you cover it up, it actually stinks a bit. Why would it stink? Well, insulation burns too. It gets really hot. There we go. There we go. So when you're starting out here deep in the groove, it's the best time to move this tip back and forth because you're welding on the center axis. So because it raised up so much on one side, I weld a weave on one side and I run stringers on the other side. A weave pulls a lot more than stringers. So until we get it even here, that's what we'll be doing. We're about halfway. So you see now I've got them all marked down there. That's 5, 6, 7, 8, 9 passes on one side and I'm at 12 on the other. So let's just keep right on going. Okay, here we are at pass 9 on the first side I'm welding. As you see, that is a 2-inch wide fillet I am putting in there. Nice big beautiful bead. And we're coming up to a higher amperage now because, well, we need a bigger puddle. This is the machine I'm using right here, the Vantage 500. And you see we're up there at 37 volts. We have all the cable is spooled down on the ground because you don't want too much of a magnetic field and it heats up and you lose some energies. Thought I'd better just show you the last pass just before the cap. It's kind of an important cap, so you better be aware that there's a little bit extra lip there because one side is thicker than the other. Just let me see this other side here. Okay, that's one pass before the cap. It's just about flush all the way across on here. And that'll give you about a 32nd of an inch right there to put the last cap on. Thought I'd show you what 20 passes look like on the other side. One pass, and the cap goes right there. Just about flush to the weld to the top. We'll flip it over and do the cap on the other side first. To put this one here, quick touch up. It'll all be insulated when I'm done. This is all the insulation that was on top of the ripper shank. I had it shrouded for 3 days. I didn't get my last shot because I was really busy trying to cover this up to keep the heat inside. This is an unwrap here this morning. Now it is down to room temperature. There was a lot of heat input into this one here, so I had to get it wrapped up real quickly to slowly cool this over that period of time. There you have it. That worked out to be about 28 passes on one side and 15 on the other. It's straight. Believe me, it's straight. Has to be. Here's the other side. That's what it looks like. Don't worry about the funny welding because, well, this is 5 inches thick on one side and 4 inches on the other. It has to be tapered. I've seen a lot of guys do stuff on YouTube and whatnot, videos, and I'm doing one here because I do things a little bit different than everyone else, and there's not that many of these things done. And I see a lot of slow stuff done. Normally I see them guys that they'll do 20 hours to do a ripper shank. I do it way less than that, but then I've got a lot of experience and I've done a lot of the ripper shanks. I can just imagine the comments that they're going to come out of this because of all the different things that I do, but it works for me. I don't have any comeback, and I put my warranty on it. Thanks for watching.